This is the list of the contents. What are the things we are going to see in the slideshow? Introduction, literature survey, technique of image segmentation, advantages, application, conclusion, and bibliography. So, what is the image segmentation? Image segmentation is an aspect of an image processing. As the name suggests, image segmentation means segmentation of a given image, that is the partitioning of the given image into the multiple segments. Typically, this is used to identify the object or the other relevant information in the digital image. It has the wide application area like image description, recognition, image visualization, and so on. Now, the main goal of the segmentation is that we should change or we can change the representation of an image. Generally, it is a difficult task in the processing to separate that particular object within the given image from its background. From the image, we can identify the particular lines and curves and highlight it. This is the literature survey, image segmentation, name of the paper, year, author, and summary. Now, there are an n number of the techniques by which we can do the image segmentation. Some of them are as follows. First is the watershed, K-means clustering, thresholding, age detection. In the implementation of my topic, I have used the age detection technique. Under the age detection technique, we can use the four operators like Sobel, Robert, Prewitt, and Canny. Each has its own and unique age detection. So, the technique number one, that is the thresholding technique. Thresholding is a simple case of a segmentation where the image contains an object with a similar gray level with uniform background. We can implement the thresholding technique by using the Otsu method. This is an example of an thresholding. This is the original image and this is the segmented image. All the features of the original image is highlighted in this segmented image. Thresholding is also called as a binarization, and it is converting the gray image f of x into the binary image b of x, y by applying the global threshold. Now the second is the Metaphorically, watershed segmentation, it is the geological watershed or the drainage that divide the separate adjacent drainage basin. Third technique is a K-means clustering technique, in which the function K-means partitions the data into the K mutually exclusive cluster, and each cluster is the partition defined. Here, the function K means partitions the data means that the given pixels are partitioned into the separate clusters. These are the examples of the K-means clustering and watershed. Here the Heston cell image, it is after segmentation, it looks like this. All the features of this cell are highlighted after the segmentation. So it is easier to identify the remote or the required areas in the image after segmentation. This is the watershed segmentation. This is the picture of the original picture of the pearls, and this is after the segmentation. All the boundaries of these pearls are highlighted here. Fourth is the age detection method. It is a well-developed method. Sobel finds the partial derivation of an image. Partial derivative has to be split in the horizontal and vertical directions. So it means that if we partial derivative has to be split in the horizontal and vertical direction or perspective. It means if if there is an image and we look at that image at the horizontal direction and the edge is also the horizontal direction in the image, then there is no edge exist. But if we look at the same image at the vertical perspective, then we see the change in the intensity. And horizontal and vertical perspective, there are the some edges. We put both together, that is a horizontal as well as a vertical perspective edges together, then we find the image with a more clear edges. Here we can calculate the magnitude from the partial derivative of the image with respective y, and now we can count the direction. If we have the edge along the x-axis and along the y-axis, then we have to find the angle by using the formula theta is equals to tan inverse of x by y. Hence we can find the both magnitude as well as the direction. Now second is the Canny. Canny has this following criteria: low error detection, good detection of an existing edge, and good localization. The distance between the edge pixel detected and the real edge pixel have to be minimized. And before applying the other filters, we have to filter out the given. If any noise is there, we have to filter it out. Then third is a Privet's operator. Privet's operator is a first order edge detection, little bit similar to the Sobel operator. It is the appropriate way to estimate the magnitude and orientation of any image. Then last is the Robert's operator. In the Robert operator, we can identify the edges diagonally. It uses 2 cross 2 mask. Here are some drawbacks like thick borderline or localization of an edges is not good and weak response to the genuine edges. Robert cross operator, it is used in the image processing and computer vision for the edge detection, and it was proposed initially by the Lawrence Robert in 1963. These are some examples of the edge detection. Sobel, this is the original image of the car parking and this is the segmented image. Here in the Canny, the coins are given and this is the black background. So the coins which are of the same intensity are separated back from its background. Here these edges of the coins are seen and here this total background, it is the black one. So the background is separated from these objects. It is the main aim of the image segmentation. Sobel. Sobel too has its application in the machine visions. Like this is the machinery part. After the segmentation, it is look like this. So the edges and the corners of this machine can be located easily by the Sobel operator. Now the advantages. Advantages of the image segmentation are wide enough. Improvement of the pictorial information for the human interpretation, and the mapping and the measurement. Automatic analysis of the remote sensing data from the satellite to identify the regions of the interest like the petroleum reserve. Mapping and measurement of the automatic analysis of the remote sensing data from the satellites. It means that if there are some remote areas and we have to identify its picture, we will get their picture easily by using the satellite. But the segmentation technique does the work of identifying the edges and more clarity and gives the more clarity to the image process. Then it goes to the radiologist. Radiologist is the science that deals with the medical imaging to diagnose and sometimes treat the disease within the body. So it really helpful to this radiologist to detect the important and suspicious structure in the body. Then software used. MATLAB is the software used in the various areas of the image processing. It is used in image segmentation, compression, and enhancement. MATLAB R2014B consists of the new graphics system, color, font, style that make the data easier to interpret. History of the MATLAB is that it was developed by MathWorks. Its initial release in 1984, about 34 years ago. It works on the Windows operating system, Linux, and Mac OS. Now, application. Image segmentation has the wide application area. Computer graphics, object detection, identification, criminal investigation, and satellite. Airport security system we can use there. Medical imaging also. In medical imaging, if there is a detection of the tumor or any computer guided surgery of the internal parts is there, so we can use this technique. It attracts the people for the research also. Practical application of the image segmentation is a content-based image retrieval, measure the tissue volumes, diagnosis study of the anatomical structure, surgery planning. If the tumor or any other thing detects inside the body or the brain, so according to that we can do the surgery planning. Internal surgery also can be done by this segmentation. Intrasurgery navigation, same. Pedestrian detection. So now it plays the major role here. In the traffic, if there are the some cars or the pedestrian walking around the signal, so we can detect those persons by this. Brake light detection, recognition task, face recognition can be done by this. Fingerprint recognition, iris recognition, and virtual surveillance. Iris recognition and all these are used in Aadhaar card. So brain tumor detection. One of the medical applications figure is given here. This is an input image and after segmentation we will get this. Means here the central part which is unclear here, it is clearly observed in this output image after segmentation. Then these are the CT scan image after the segmentation. This is a brain CT scan and this is a diaphragm CT scan after segmentation. Computer guided surgery. This is some medical application. This is a prostate cancer cell detection. And this is a face recognition task, iris recognition. Let's conclude the topic. So, different technique developed for the image segmentation suits to the different images. Neither of the technique is perfect for the given image. Each has its own result which may be useful in a different fields. All segmentation method perform well for the one particular image. Hence neither the single segmentation it is applicable for all the images to be segmented. This is the references taken and some of the references are from this website like MathWorks, Wikipedia, GitHub and ResearchGate. Thank you. Now let us look at the MATLAB code. Here first is CLC, that is clear. Clear the command window. Close all, it will close all the figure. Clear all will clear the screen of the command window. Now this is my color image is a one variable. I am read, it is a one function to read the image from the specified folder, that is the image will be tulip.jpg. My image is equals to RGB to gray, my color image. My color image is the variable name in which the tulip.jpg image is stored. So to that image, we are converting that image to the gray color by using the function RGB to gray. And the result is stored in the my image. Here I am show is equals to my image. The given output or the result is shown by using the function I am show. Output is shown by this I am show. Title by using this line, that is title in bracket original input, it will give the title to your figure. The use of this figure is to separate the different images on the different windows. Sobel dot horizontal. Sobel operator it is used. Now for the horizontal edges, the MATLAB code and the MATLAB command will be Sobel horizontal, it is a variable name is equals to age. My image will be the output, that is grayscale output. This is the method, and horizontal. This is the syntax. Age MATLAB command it is used to apply the different types of age operator. Here like Sobel operator, Canny operator, Privet's and Roberts operator. This subplot function 3, 3, 2. Now the output window will have the 3 rows, 3 column, and the position of the image will be the 2. Here the output window will have 3 rows, 3 column, and the output image, that is my color image, will be the position will be 1. So moving backward toward the horizontal, Sobel horizontal. Horizontal edges are showing or it will be shown by this I am show horizontal. This bracket represent the showing the horizontal edges of the image for all the values. Then title will be given as Sobel horizontal figure. Then this code will work for the horizontal images, and after this is after for the horizontal images. This is the output of the Canny operator. This is Laplacian, Privet Sage operator, Robert Sage operator, Sobel operator. It is by horizontal as well as vertical edges. This is Sobel. Here only the vertical edges will be highlighted, and here the horizontal edges will be highlighted. And it is the grayscale image, that is the original colored image. It is converted into the black and white image by using the function RGB to gray. That's all.